Salam, peace be upon you. We're going to begin with a woven summary of what we have certified so far in episode 14, so we don't lose the thread. We have certified that public structure starts only from differences in phase, meaning delta phi, inside licensed finite windows with passports. We have certified local lifts, careful cuts, and excisions to create a clean certified domain D. We have certified A equals D phi tilde, finite jets up to an honesty ceiling n max, invariant stress tests, and atlas stitching by overlaps. We have certified loop memory as holonomy and loop grammar by composition, and we have certified that in defect-free domains, meaning is the class, not the curve. Now we take the next step, and it is the moment where many sciences secretly become mythology if they are not disciplined. Because this is the moment where people start pointing at a strange behavior and saying, that must be a thing, a particle, a monster, a special substance, a hidden force. We are not allowed to do that here. Here, in episode 14, we are building a compiler, not a cosmology, not a story of how the universe unfolds. We are building the timeless rules for what can be publicly read at all. And that means when something breaks, we don't get to invent a new being. We must type the break. So part 31 is where we learn to speak the language of breaks without turning breaks into magic. Let's anchor ourselves in the always true line. Episode 14 does not describe reality. It specifies the conditions under which reality can be described at all. And now we say the toolchain out loud, because every structural claim must flow through it like a legal pipeline. Licensed window, then passport with coherence and identifiability, then nmax and uncertainty, then local lift, then cuts if needed, then excisions, then a certified domain D, then A equals D phi tilde, then finite jets up to nmax, then invariance collapse, then topology and defects, then invariant bases, then stability and entities, then scale stratification, then escape test, then handoff. Imagine we're mapping an island, not with fantasy, with a strict public method. We stand at a place, take readings, and we write a local description. That local description is like a jet, a little bundle of what's going on right here, up to the order we are allowed to speak. Then we step a little, take another reading, write another local description, and we keep doing that. If the world is smooth there, these local descriptions stitch, they blend, they agree on overlaps. We get a coherent map. But then, sometimes, we reach a place where the whole method refuses to continue. Not because we are lazy, but because the rules of our language do not permit a smooth continuation. We try to extend the lift, we try to extend the jets, we try a different chart, we try a different cut, and the refusal stays. That refusal is what we call a defect. Not a thing, a refusal, an obstruction. This is the cleanest and most honest way to say it. A defect is a certified place where legal structure cannot be smoothly extended. And now let's bring it down into everyday life. Think about knitting. If you're knitting a smooth scarf, stitch after stitch, the pattern is consistent. Then you hit a knot in the yarn. That knot is not a new kind of stitch. It's a place where the smooth procedure breaks. You can try to pull it, rotate it, approach it from the other side, but it's still a knot. If it is a real knot, it persists under every reasonable attempt to rearrange the yarn without cutting it. If it disappears when you simply untwist your hands, it wasn't a knot. It was your bookkeeping. That is exactly our standard here. So our mission in this part is simple to say and strict to execute. Define defects as the places where lifts and jets cannot extend smoothly under legal typing. And classify them by codimension, meaning, are we dealing with a wall-like obstruction, a line-like obstruction, or a point-like obstruction, relative to the domain. And our core is even simpler, and it is the heart of the holophase discipline. Defects are not things. They are persistent obstructions that survive representation changes. And they are exactly why topological tokens like winding numbers and holonomy do not trivialize. Now we need one more reminder that must appear in every part. Try unity. Every certified structure has 3 simultaneous readouts of the same differentiation. We can label them omega, kappa, nu. Omega is cadence, the rate at which comparisons change. Kappa is texture, the pattern of variation. Nu is drift, the transport of patterns. But we do not treat time, space, or motion as primitives. These are readout labels only. Even a defect, even an obstruction, must be something that is consistent across readout choices. If it depends on a particular storytelling of time or space, it is not certified here. Now, before we do anything else, we have to install the excision mandate, because this is where people get sloppy. If a defect is real, then calculus is not allowed through it. It is not legal to take derivatives through the cliff and then pretend we are still honest. A defect is a hole in the domain of smooth speech. So we excise. We cut out the collar, a little tube or ball around the obstruction, and we work in the remaining domain D prime, where the language is legal again. That means we treat defects like we treat electrical sockets that are damaged. We don't plug into them and hope. We isolate them, label them, and route our wiring around them. And the label is not poetry, it is an audited classification. So now we introduce the obstruction audit protocol. We're going to weave it as a story, but the gates must be real. Picture a museum with priceless artifacts. The museum has rules. You can walk in certain areas, you must stay behind ropes, and you must not touch the glass. The domain where you're allowed to walk is our certified domain D. Now suppose a visitor says, "There's a ghost in this hallway." We don't shout "ghost" and add a new primitive. We run a protocol. Gate 1 is neighborhood legality. We ask, is this hallway even part of the museum we allow visitors to walk in? Or is it behind a rope, or under renovation, or already declared off limits? If it's off limits, the ghost is meaningless inside our public language, because we already said we won't speak there. If it is inside the allowed area, then it becomes eligible for a real test. That is our first discipline. We never declare a defect inside a place we already excised for aliasing, for cuts, for boundaries, for instrument failure. A defect is not whatever we don't understand. A defect is what remains as an obstruction after the domain is legal. Gate 2 is the excision color gate. This is where we turn a spooky point into a proper scientific object in the compiler sense. We don't just put a dot on a map. We remove a small color around the dot so that the boundary of what remains is smooth enough for our jets and our A field to be legal. This is crucial, because otherwise people pretend the singular place is still part of the domain and they take derivatives across it. And then later they act surprised when infinities appear. Infinities are often just the penalty for illegal calculus. So we excise minimally. Not too big, not too small, just thick enough that on the new boundary the language works. Now comes the most important gate. Gate 3 is invariance under redescription. This is the is it real or bookkeeping gate. We take our candidate obstruction and we apply every admissible change of description. We change the lift, we change charts, we relocate cuts. We test gauge invariance, meaning we can shift phi by a constant without changing anything public. We refine the window if that is allowed under the passport. We ask, does the obstruction persist? If it vanishes under an admissible redescription, it is not a defect. It is bookkeeping noise, full stop. This single gate prevents a huge amount of historical confusion, because people have often mistaken the defect of my coordinate choice for a defect in the world. So the test is brutal and clean. Can we chart it away? If yes, it is a ghost. If no, it is real in the compiler sense. Then gate 4 is the codimension classifier. This is how we stop our language from being vague. We classify the abstraction by how it sits inside the domain. If the domain is three-dimensional in the relevant readout, then a wall-like defect is codimension 1, a sheet in space. A line-like defect is codimension 2, like a thread. A point-like defect is codimension 3, like a dot. Codimension is just a way of saying what shape is the abstraction compared to the space it lives in. And codimension matters because it tells us what kind of topological probe can detect it. A line defect can be encircled by a loop. A point defect can be surrounded by a sphere. A wall defect changes what side you're on. Now let's bring this down to the simplest everyday analogies, because the word codimension can sound heavier than it is. If you're driving in a city, a codimension 1 obstruction is like a roadblock that spans the whole street. You cannot cross without leaving the legal road. A codimension 2 obstruction is like a pole in the middle of a plaza. You can walk around it, you can loop it. A codimension 3 obstruction is like a single nail sticking out of the floor. Small, point-like. You can step around it, you can circle it, but you must not step on it if you want smooth walking. And now we install the deep carry of this part. Objects begin as failures of smoothness that won't go away. This is not philosophy. It is a method. We do not begin by declaring there are particles. We begin by trying to extend lawful structure everywhere inside a certified domain. Where it fails persistently, we get a defect token. Later, in other episodes, people may interpret defect tokens as objects. But here, we only certify the abstraction and its type. Now let's give the simplest formal backbone, spoken for audio. We remember that the only primitive is phi, a map from X to S1, meaning phi assigns each event a position on a circle. S1 is the circle. Public meaning is only differences, delta phi, in licensed windows. When we choose a local lift, we get phi tilde, a real-valued version of phase inside the window. Then we define A as d phi tilde, meaning A equals the derivative of phi tilde. This A is our first public carrier, because it does not care about adding a constant to phi tilde. Then we build jets, meaning derivatives of A and so on, up to our ceiling. Now, a defect is where this lift and jet story cannot be extended smoothly, no matter how we do the lawful bookkeeping. So the defect is not a bump. It is a place where our legal story ends. Here is a powerful child-simple example. Imagine you're drawing a smooth line on paper, and you promise the line will never lift from the page. You draw smoothly, and suddenly your pen hits a tear in the paper. You can't draw across a hole without leaving the rules. You can try a different pen, you can rotate the page, you can zoom in, but the hole is still a hole. The object is not a new kind of ink. The object is the hole, the obstruction to smooth drawing. That is a defect. Now, because we are in holophase, the clearest way defects show up is through loops. In part 28, we learned loops can carry memory, and that memory is holonomy. Holonomy is the phase accumulation around the loop. Holonomy of gamma equals the closed integral around gamma of a.dl. And because a is d phi tilde, you can think of it as the total phase change you pick up when you go all the way around and return. In a clean, defect-free, simply connected domain, holonomy must be trivial for loops that can shrink to a point. That is part 30's clean room principle. Meaning is the class, not the sketch. If you can smoothly deform one loop into another without crossing any excised region, the invariant must match. If you can shrink it to nothing, the holonomy is 0 modulo 2 pi. So when you measure a non-trivial loop memory and you cannot remove it by lawful redescription, you have found an obstruction, a defect. Now we need to merge the strengths of both versions. We want the vivid everyday story, and we also want the strict compiler structure. So we'll walk through a concrete defect discovery story using our gates, and we'll do it across scales. First, a human scale story, the hidden pillar in the room. Imagine a large, empty warehouse. You're blindfolded, but you have a rope attached to your waist, and you walk a loop and return to where you started. Your friend tells you, if the room is empty, any loop you walk can be slowly shrunk down to a tiny circle near the start, without bumping into anything. That's the clean room principle in everyday terms. But suppose you keep shrinking your loop and you keep bumping into something. There's a pillar. You didn't know it was there, but your loop remembers it. You can deform your path in many ways, but as long as you insist that the loop encircles the pillar, you can't shrink it to nothing. The obstruction is not a magical force. It is the pillar as an obstruction in the domain of your motion. Now translate. In our phase language, the pillar is a defect. The loop memory that refuses to disappear is the topological token. The same logic. Second, a physics scale story. A vortex in a superfluid. In superfluid helium, the phase is meaningful because the flow is connected to phase gradients. In a smooth region, the flow is irrotational. It wants to have zero circulation around loops. But experiments show stable vortex lines where the circulation is quantized. That quantization is basically a winding number, an integer. That integer is the token. Now, how do we certify it without smuggling vortex as a thing? We do it like this. We have a licensed window in the fluid. We have a coherence threshold. We verify the superfluid is coherent enough for phase talk. We pick a domain D where our measurements are legal, not near walls, not in alias zones. We attempt a local lift and we compute A equals D phi tilde. Now we test loops. We take a loop gamma that encircles the suspected line. We compute the holonomy, the loop integral. We find it is 2 pi times an integer n. Holonomy equals 2 pi times n. Now we do the gate that matters, redescription. Can we choose a different lift or chart that makes the obstruction disappear? If the answer is no, if every lawful attempt still forces the phase to jump by 2 pi times n when you encircle, then the obstruction is persistent. We excise a thin tube around the line so that our domain becomes smooth again. Now we classify. The defect is a line in a three-dimensional domain. That's codimension 2. The charge is n. We write it to the ledger. That is it. We did not need particle talk. We did not need force talk. We did not need dynamics. We only needed legality, invariance, and topology. Third, a cosmic scale story. Maps of the sky. Imagine we are building an atlas of the cosmic microwave background. We have overlapping windows from different experiments. We stitch them. We check triple overlap closure. Now suppose in one region the phase-like pattern seems to have a persistent twist when you loop around it. The loop memory is non-trivial, and it doesn't vanish under lawful redescription. Then we do not say a cosmic monster lives there. We say there is a certified obstruction of a certain codimension in the readout domain. We excise a small region, classify the defect type, and record the loop tokens around it. Again, the object is a persistent failure of smooth extension. Now, because we're merging two versions, we must also include the classic Dirac string lesson, because it perfectly demonstrates the difference between a real defect and a bookkeeping artifact. So listen closely. because this is one of the most powerful examples of gate 3. Physicists once found that if they try to describe a magnetic monopole using one global potential, they seem to get an ugly singular line called the Dirac string. That line looked like a defect, but when they used the proper language of overlapping charts, exactly what we have built in episode 14, the string could be moved and effectively removed as a physical object. It was not invariant, it was chart removable. The only persistent obstruction was at the monopole point itself. So, by our rule, the string is a ghost defect. It fails persistence under admissible redescription. It is bookkeeping noise. The real defect, if it exists, is the point obstruction. This is what it means to demystify singularities. Many singularities are not deep. They are illegal mathematics done in the wrong domain with the wrong descriptive grammar. And now we state the prediction and the falsifier in the simplest, strongest way. Prediction. True defects persist under all admissible redescriptions. Fake defects vanish when bookkeeping is corrected, when the lift is chosen properly, when the charting is done correctly, when cuts are relocated lawfully, when the passport is respected. Falsifier. If we claim a defect, and then an admissible redescription removes it without crossing excluded sets and without changing the passport, then our defect claim is falsified. It is not a defect. It is a bookkeeping error. That falsifier is not aimed at nature. It is aimed at us. It is our self-policing device. Now we must also install the operator guards discipline that appears in your canonical prompt because defects and undefinedness are married. We are not allowed to write expressions that assume smoothness where smoothness fails. Every operator carries guards. Every derivative must declare where it is legal. Singularity is not mystery. It is typed failure of operator legality. So whenever we see an infinity, we don't clap. We ask, did we legally apply an operator outside its domain? Did we differentiate where we promised differentiability but did not have it? If yes, the infinity is not a discovery. It is a refusal certificate. Now let's turn codimension into a vivid, engaging story that an average listener can hold. Imagine a world made of rooms. A codimension 1 defect is like a wall that splits a room into two. You can't pass through smoothly. You must go around through a door. The obstruction is surface-like. It has two sides. That's like a domain wall in a magnet. The orientation flips across a sheet. A codimension 2 defect is like a pole in the middle of a room. You can walk around it. And because you can walk around it, loops become meaningful probes. That's like a vortex line. You encircle it and you get a winding number. A codimension 3 defect is like a single locked safe embedded in the floor. A point. You can surround it in all directions. That's like a monopole-like obstruction. Codimension tells us what kind of around is relevant. Now let's merge the strongest clean room versus obstruction framing. In part 30, we said, in the clean room, only the essence matters, not the scribble. If two loops are homotopic in a defect-free certified domain, they must give the same invariant. Part 31 says, when that fails, don't panic and don't mythologize. Run the audit. Most of the time, apparent failures come from one of four things. You hit a boundary you didn't admit, you crossed a cut you didn't log, you walked through an alias zone you should have excised, or you have a hidden defect you haven't typed. That is why this part is powerful. It turns weirdness into a decision tree that produces either correction or a certified defect token. Now we include a stress test explicitly, because it is mandatory. We take a candidate defect region. We test constant shift invariance. Phi goes to phi plus c, where c is a constant. Does the defect vanish? It must not if it is real. We test lift shift. Choose a different local lift of the face. Does the obstruction vanish? If it does, it's fake. We test chart changes. Cover the neighborhood with different overlapping charts. If one chart makes the defect disappear entirely, it is not a defect. We test cut relocation. Move the cut line, the bookkeeping seam. If the supposed defect moves with the cut like a shadow, it is bookkeeping, not structure. Only what survives these tests is allowed to be called real here. Now we must produce the audit artifact in spoken form, like a ledger entry, because episode 14 lives on audit trails. So here is what we write to the ledger in part 31, said as a vivid but strict record. We write a defect candidate ledger entry, window passport identifier, coherence score gamma, identifiability and NMAX, uncertainty budget, domain D description, neighborhood legality certificate, excision color map, redescription persistence report, codimension classification output, loop token measurements around the excised color, and finally a verdict, certified defect, or revoked as bookkeeping. And if it is revoked, we also write a failure localization note. What changed under redescription, what chart removed it, what cut relocation exposed it, what passport refinement dissolved it. Because a revocation is not embarrassment, it is science. Now we include one more cross-scale analogy, because you asked for across scales, and we want people to feel the same logic from everyday life to physics to data. Think of data fitting. You fit a smooth curve to points. There is one stubborn cluster that refuses to fit no matter what you do. First you ask, is this cluster in an area where your sensor is unreliable? If yes, it's already excised, not a defect. If no, you ask, does the anomaly persist under admissible redescriptions of your model? For example, change coordinate scaling, change basis functions, change smoothing parameters within your declared legal model class. If the anomaly vanishes, it was bookkeeping. If it persists, it is a real feature of the dataset. Now classify. Is it a line of anomalies, a point, a boundary? That is codimension thinking in data space. Then excise if needed to keep your smooth model honest and record the anomaly as a typed obstruction. That is part 31 in a modern scientific context. Not metaphysics, but reproducible error discipline. Now we end by welding the carry into the listener's memory in a single sentence they can repeat. Objects begin as failures of smoothness that won't go away. And now, the revocation clause must be said in the strongest form, because it is how we stop drift. Revocation clause. If a claim defect is chart removable under admissible redescription, it is not a defect. It must be reclassified as bookkeeping error, and every downstream output that depended on treating it as real is revoked and sent to the negative archive. That clause protects the framework from superstition. Now, before we close, we must keep our episode 14 firewall intact. We do not talk about how defects move, how they interact in time, how they cause forces, how they evolve. That belongs to later episodes. Here we only certify structure, obstructions, their codimension, and the topological tokens they force. So the closing picture is this. Reality gives us differences, delta phi, in windows. We license those windows. We extract local structure via A equals D phi tilde and jets. We test invariance. We build loops. In clean rooms, only classes matter. When classes refuse to trivialize, we do not invent beings. We run an audit. We excise minimally. We classify the obstruction by codimension. We attach topological tokens. We write it to the ledger. We keep going, honest. Always. Peace be upon you.